Now there are some good iOS commands that you can use to gather information about the OSPF data structure so that you can analyze the flow of routing. And of course it's always real time. Real time in that when you type the command show and hit enter, that's what it was. If you leave it on the screen for 10 minutes, it could change. Alright, so for the interfaces, show IP OSPF interface shows you the active interfaces. For the neighbors, show IP OSPF neighbor shows you all of the neighbors, including the states. And if you had cleared your neighbors and kept hitting this command over and over again, you could almost watch it go through each of the little steps from the initialization to the two-way to the exchange, all the way up to full. The database, the link state database, show IP OSPF database. If you're an ABR, you'll see all of the databases for all of the areas that you're connected to. Now remember, that's the information from the OSPF database that's actually going to go into the routing information base, what we call the RIBs. That's where we conduct the SPF calculation and come up with the best routes. The best routes you can see with the show IP route. And if you want to see just OSPF ones, show IP route OSPF. Now you can also look at statistics, which is very good to see how often you're doing these calculations and other information about the performance of OSPF. So you have the show IP OSPF statistics as well. Now debug will allow you to see a couple of different things that are happening. If you do the debug IP OSPF packets, you're going to be able to see the exchange of information, right? All of the back and forths between you and your neighbors. If you do the show IP OSPF monitor, you're going to see the changes in the routing information as they're done. When you do a new SPF and why you did that, and the entire changes to the database, the link state database. The show or the debug IP OSPF adjacencies, helpful for you to be able to see the state changes as neighbors are coming up and as the two are negotiating their processes or any changes or errors occur. Debug IP OSPF events, a great way of being able to capture errors, especially in errors becoming neighbors to begin with the exchange of hello packets and other types of issues that come up. Well, here I am on router 1, and we're experiencing some suboptimal routing. And to show that, let me get into this regular exec mode. And what I'm going to do here is do a ping to this address 10.1.7.2, which by the way is a perfectly legitimate location. It's reachable for our network. But what I'm noticing is that instead of taking my first hop through the frame relay cloud, that instead I'm taking a much slower serial interface, a 64K interface, as my first hop and then going into the frame relay cloud instead of going there directly. So when I do my trace route to that same address, we can take a look and see what it puts together. And my next hop, according to this, is to going across that serial interface to a neighbor. And then from there, it goes into the frame relay cloud and gets to the destination that I want. And so there it is. There's the path going through the serial neighbor on the 10.10 address that you see. And then, of course, boom, hitting the other location. All right, so that's not necessarily the path that I want to take. And really what we're going to do is we're going to try to figure out why I'm not going into my frame relay cloud that I would like to go first. So what we're going to do is we'll start off with the command show IP route. And with the show IP route, we see that we are learning that particular route, 10.1.7 route. And in actuality, we're taking even a different path. We're going through a switch interface to get there. Instead of going directly into the cloud, it's still actually a little bit, a couple of hops away. But our goal is that we should be getting it through the frame relay cloud. That's our service provider. So I see that showing up here as a route that is at least legitimate. But like I said, it's not necessarily the route that I had hoped to see. So what we're going to do then is try to figure out whether or not we are getting our neighbors off of our frame relay interface. So one of the things that makes me wonder about this, of course, is do I have all my OSPF neighbors? So the next thing I do is the show IP OSPF neighbors. And I only have 2 neighbors, when in actuality I should have 5 separate neighbors. I have 3 point-to-point frame relay interfaces, and I don't see any of them in there. I see only my serial neighbor and my neighbor on the fast Ethernet link. All right, so that leads me to wonder if maybe there's something up with the show IP OSPF interfaces that might be causing a problem. Now, when I look at the interfaces, and I'll just scroll through all of these very quickly. All right, so there we go. We got them all. So we'll scroll back up here towards the top. All right, so I am advertising these loopbacks only for the ability to create the illusion of more networks than we really have with our 4 routers. I know that the serial 02 is working well. And again, it's a point-to-point. There's that 30-bit mask type point-to-point. And fast Ethernet we know is working. Here are the sub-interfaces, the sub-interface 105, 103, and if we go down here, 102. All right, so these tell me that they are up. They're saying that they're up and that they're making the connectivity. But as I look through the rest of this, I begin to see perhaps part of the problem. And that is, by my topology, they should be connected to area 0 and not to area 10. So while I don't have neighbors with them, I can begin to say, well, all right, this might be an indication that we have a problem because according to our rules, you should be matching up on the same areas to be neighbors. Okay, so let's try doing a show log, and we'll include OSPF as our options. Oh, don't see anything there, so we'll just say show log, and we'll look to see if we're getting any of these messages from our setup. And all right, so we're not getting any of the logs, and at least that I can see from there anyway, any particular messages between the two of us. So nothing there is making me wonder. So I'm going to say, well, let's do a debug then of IP OSPF, and let's take a look to see if we're having any problems with the adjacencies. So we'll look at adjacencies for the debug. And we'll also do a debug. Well, so okay, with OSPF, it's the hellos that are responsible for exchanging areas. So we'll debug the hellos and see if we're going to get any type of information to our console. And we're also going to make sure that we have the logging console set up to allow up to, that's a global config command. We're going to make sure that we have the logging set up appropriately to allow us to see debug on our screen. All right, so here I see some hellos going out to our neighbors on area 10, and I see I'm receiving hellos, and those hellos are coming in from our same interface, but here it is. We're seeing an invalid packet, and a little harder to see, so let me quickly do a UAll to turn off the debug. And right here I'm seeing the error received message, an invalid packet, mismatch area ID from the backbone, and of course we're still getting flooded. Even though I've turned off the debugging, I'm sure these are just some of the things that are still kind of stuck in the queue. So once this thing slows down, I'll make sure that I did do the undebug all. Oh, that's it again. We've got to be in the right mode to do that. So Control Z and U space all for undebug all. There we go. And here it is. So now we're seeing the error received, invalid mismatch area ID from the backbone area. It says it must be a virtual link, but not found on that interface. And the reason for that particular message is simply to say that I can't have an interface in area 10 connecting directly to an interface in area 0. I have to have a virtual link if I want to do that kind of trickery. Well, so now we'll take a look at our show IP protocol to see if we can look at the configuration of OSPF, or of course we could do the show run to take a look at what we have. And what I can see here is that I have my 10 networks that are connected to that frame relay, all configured with area 10 instead of area 0. And it makes me think that perhaps in that configuration something was fat fingered. So let's go to router OSPF 50. And let's do a no network command. And so those networks were the 10.1.5.0 network. And let's see, and that was with a 0.0.0.255 area 10. So we'll kill off that one. The other one I saw was 2 and 3. So I scrolled back up there, so I'll use my up arrow and just change that 5 to a 2. And then we'll change that to a 3. And we'll kill off all those bad networks. And hopefully that'll stop generating the information that we're getting. And now I'm going to go and put in the new network commands. And in fact, I'm going to cheat just a little bit for the sake of time. I'm going to put in a network command that encompasses all of those. And I'll put that into area 0, which now this isn't always the best solution. You have to remember that sometimes if you do these types of things, you may be advertising more interfaces than you mean. But that little network command would probably do the job. Oh, and there we go. I'm seeing my messages saying that the loading's done. If I do a do show IP OSPF neighbor, I am now seeing those neighbors show up on those interfaces, which is great. And if I say do show IP route, and I think it was to 10.1.7.2 that we were trying to get to. All right, so I still have just the one route at the moment, but with any luck, we'll start seeing some of the other routes pop in there. Now, the one last command we haven't done, as I'm waiting for the rest of the neighbor interfaces to pop open, is the show IP OSPF database. And the database command is a very important command for us. So as I added these new networks in, I should start seeing in area 0, notice area 0, I should start seeing their router IDs coming in, or their router advertisements, the type 1s. And I saw 3 new ones. Look at the age. Those are 3 fairly new ones. They each have their link counts telling me how many routes that they have. And it looks like only one of them have a transit route being generated. In fact, that's actually mine, because I have that fast Ethernet network associated with mine. So I have one type 2. We have no inter-area working going on here. So no type 3s and no route redistribution for any type 7s or 5s, depending on where they're entering our network at. All right, so and the reason, again, that this is important is that by seeing these type 1s coming from these 3 new routers, the ones that are very young in their age, that's letting me know that that I am receiving the route information that I was not receiving before when I had the misconfigured area ID. All right, so that was a quick way of going through the commands, kind of as we talked about in our lecture, of going through and trying to troubleshoot OSPF.